are all off when you walk in the building. We also want to remind those students that like to have their cell phones out in class. The only time that you need to have your cell phone out is when the teacher has given you permission. If the teacher does not give you permission to have that cell phone out, the teacher can take said phone. If you refuse to give your cell phone to the teacher, please understand that you will receive some sort of discipline, and your phone can be kept up to 24 hours. Also want to remind you, meaning if your phone is out, even if you're not on it and your phone is out, teacher can take the phone. Our strong suggestion is that you would not start charging your phones in the classroom. Your phone should have been charged last night while you were at home. So if you are charging your phones and they get taken or anything like that, that is on you because the school is not where you are supposed to charge phones. I also want to remind those students and teachers that no student should be in the hall the first 10 minutes of class or the last 10 minutes of class. Also, every student in the hall must have a hall pass. Please make sure, students, that when you are in the hallway, if it's during class changes, that you do not have your music on or blasting, because at that point, it is a dead period. Meaning, for those people that are confused about what I'm saying, we have two things, a live period and a dead period. A live period is during lunch and during class changes, and the dead period is during classes, meaning if you have to go to the restroom or run an errand, your music should not be on because that is a dead period, because it is during class changes. We also want to remind those members of the gospel choir that you will be having practice today with Mr. Watlington. PSAT, pre-administration, will be conducted tomorrow in the Media Center beginning at 2:45. All test takers must complete the pre-administration.
One last thing, we do have just a slight issue with students who are entering the teacher's workroom and lounge. Students, the teacher's workroom and lounge are for state employees. That means that if you are in there and you are not on the payroll at Lexington Senior High School, I have not employed you, and you have no business in there, regardless of who instructs you to go in there. Teachers, there is no reason why students should be asked to go in the teacher's workroom or lounge. Again, if they are not on the state payroll, they are not employees of Lexington City School, Lexington Senior High School, they should not be asked to go get papers off printers, drinks, or snacks. Any student caught in the teacher's lounge for any reason before or after school, during school, will be subject to a penalty leading up to suspension from school. Please make sure you adhere to this policy. Thank you, and let's have a great day.
We don't care about the people on the table. It's not that, does it? No.
Are we done with the opening? Right.
Is the fifth question
question asking if it, like, when it goes from an excited state to the ground state?
So what now?
Is the fifth question asking, like, when it goes from an excited state to the ground?
Yes. Yep, this is day one. Your openings and your Christmas from yesterday, as well as your labs, are both all graded. Everything is in Power School, but I will not return those to you until Friday. And that's because all makeup work is due to me by Thursday afternoon. And that way, those of you who have weaker fortitudes aren't tempted to give your work to people who still have to turn in work. Yes, my dear.
Oh, wait, the stuff is in the grade up.
I'm gonna grease my shoes. I'm not gonna break that out. This is only time. Sure, anytime.
Wait, you said that they're in the quizzes?
Yes, they are.
You said what?
Everything that you gave me so far is in Power School. So if you've turned a lab report, that's in Power School. Openings are in Power School. Yesterday's quizzes are in Power School. But I will not return that stuff to you until Friday. Lab reports, because people are making up labs today. So those won't go out until they've had an opportunity to turn theirs in. They're due, they're of course due tomorrow. If you don't turn it in tomorrow, the latest I will take is Friday. So make sure if you don't turn it in tomorrow, you turn it in by Friday with a late grade. Openings have to be in to me by tomorrow afternoon with late work, so you have until tomorrow afternoon. And any missing quizzes or missing work is due to me by tomorrow afternoon. So if you have missing tests, whatever I said that was, quizzes, that's all due to me tomorrow afternoon also. By the time I leave, 4:30, 4:45, it's all due. Okay, so check your Power School. Some of you are not real good about checking Power School. Check it, see if there's anything you want to make up. Now, I would tell you if you have a missing test, there are some people in here with a missing test. All right, make it up. It's the biggest thing that will affect your grade. Even if you're going to fail it, a 0 hurts more than a 40. Okay, 40 helps your average, even if it's an F. Okay, make it up. Beyond that, labs hurt more than quizzes. The zeros hurt, even if you're going to fail it. A 50 helps more than a 0. So make the stuff up. Beyond that, I don't have a lot to say about grades. Grades close out sometime next week. I will not go to the end of the grading period because I have to have time to make up missing work. Okay, so I've got to find this class usually sends us the end of the grading period date to cut stuff off, and she hasn't yet. So it'll probably go sometime into the early part of next week, and I'll cut off grades. The test will probably be the first test grade of your new quarter. I will not put that on this quarter. We'll go on next quarter. So you've already had your last test grade. So the only thing you'll be getting at this point will be homeworks and quizzes for going this quarter. I'm going to pick on Serenity for a minute. She's like, Ms. Wall, you keep putting me in grades. The grades not moving. For the most part, unless you have a missing test or something huge and a bunch of zeros, your grade is not going to move a whole lot. The reason for that is you have somewhere in the ballpark of 30-some grades, might even be pushing 40 at this point. Unless something drastic happens in your grade, like I'll pick up my alley for a minute. Her grades are all really up here. So unless she gets a 0, which is drastically different than everything she's got, she's not going to see any movement in her grade. It's largely flatlined. Okay? If she made a 0 because it's so different from everything she has, she's going to see a drop. Okay? Any questions about that? All right, let's talk over it. What's the photoelectric effect, Sumatra? Okay, now you got to talk loud enough I can hear you. I'm getting old. Okay. All right, number 2. Are energy or frequency related, Michaela? They're directly proportional. Okay, use that word, directly proportional. All right, number 3. What is required for an electron to be emitted from a metal? Franco, you want to tell me that one? Okay. Can I get that one, Precious? Okay, I need something more than that. Okay, high enough frequency, I'll take that. Which is called a quantum, I'll take that. There's one more. I'll take. There's one other answer I'd take. High enough frequency, a quantum of energy. There's one more answer I'll take. Anybody got it? Gonna be hit by something else. Starts with a P. Hit by a photon. Okay, because a photon is a particle that has I heard it over there, a quantum of energy. All right, any of those answers work. All right, what's a photon? Danielle. Yep. Did y'all hear? I barely heard her. Say it a little louder there. A particle with a quantum of energy. All right, what happens when an electron returns to the ground state? Serenity, can you tell me that? What? It is emitted. That's an okay answer. Can you tell me what is emitted? There's 2 answers that I'll take. One's better than the other. Franco? I'm crazy about that one. Ian, what did you got, Michaela? Light is one I will take. Aurora, you got a different one? Light is okay, because that's what I showed y'all. There you go. EMR is the better answer. Okay, it can be any type of EMR. All right? Light is what I showed you, because you could see that one. But it can be any type of EMR. All right? What color of light has the lowest frequency? The lowest frequency. What was it? All right, I hear red. Lowest frequency. Yeah, red. Are we okay with that and how to get it? I don't see any no's or shaking heads out there. Are we okay on how to read that? Okay. And the last one just went away. All right, what type of EMR has the longest wavelength? Radio waves. You okay with that one? All right, can we talk homework?
Yeah.
All right.
I have a question that was on yesterday's quiz.
Yeah.
What is the definition of hertz?
1 cycle per second.
1 second per second.
I don't know.
There's only 2 people who got it right.
Is that gonna be on this test? I mean, this quiz?
I'm not going to tell you that. Let me just find the. Yeah.
If that's
Can we go over what?
I know it's from not yesterday.
I guess. All right, so we started at 12. What's a quantum? Minimum amount of energy. What's a photon? A particle with a quantum of energy. We good on that? Quantum is a minimum amount of energy. A photon is a particle that carries a minimum amount of energy. Franco, do you need me to hold that for the period? Princess, same for you. Did y'all ignore Miss Harvey up there on that whole phone thing? Put those things up. Alright.
Is it okay if, like, we were asked what a photon was in the quiz and we said it carries a quantum of energy?
You need to tell me it's a particle that carries a quantum of energy. Okay, be specific as that's a part. All right, so energy and frequency are related how? Directly. What's the ground state?
State of lowest.
State of lowest energy. Now, the excited state is the state of what? Higher. They don't say
That's
highest,
what I'm
just
confused
higher.
why you would say EMR is a minute, because like, isn't it,
Because it doesn't have to be visible light. If you look at your Bohr model,
because I put energy, I didn't put light. And I don't get how that couldn't be light.
energy is just not very specific. I want you to be able to tell me that it is a form of EMR, electromagnetic radiation. Okay? It's not that energy is wrong. And if you wrote it, I probably would give you credit. Okay? Because it's not specifically wrong. All right? But I want you to be able to tell me it's a form of electromagnetic radiation. Okay? So, if it falls in this range, it would be visible light. But it doesn't have to be visible. It can be UV. It can be infrared. Oh, we're stupid. All right? It could be radio waves, microwaves, ultraviolet, X-rays, or gamma. Okay? Technically, they're all forms of energy. All right? But I would rather you say that it's light or electromagnetic radiation. All right? So, number 16. What happens to an electron when it goes from the ground to the excited state? What does it have to do?
EMR is absorbed.
You can say it's absorbed. I don't even care if you say EMR. I'd even be okay if you just said energy is absorbed. As long as you know it's absorbed, I'm cool.
That's what I just.
I'm fine if you just said it's absorbed. I just said that.
So when it's emitted, it's different.
That's different because you give off light. You don't give off anything when you absorb.
Okay, so I can write energy is absorbed.
You say energy is absorbed. All right. 17. When you go from the excited to the ground, that's when you emit something. Yes, and you emit electromagnetic radiation. All right. So 18 is what we worked on yesterday. It's the same question I actually wrote on the board. So I would hope we all got this one right. So we went from 6 to 2. I didn't mean to pick one from the homework. All right. So the Bohr model goes from, what color do I have? Probably red. Yep. All right. So 6 is here on this outer ring. 2 is here. Remember what I said. You always go from the bubble to the arrow. So you keep coming around. The little bubble is here. The arrow is right there. So it points there. All right. And that comes down to number 410. So 4.1 gives us what color? Violet. All right. But the next one we didn't do yesterday. So 3 to 2. Okay. So 3 is here. 2 is here. So the bubble, if we keep coming around, is where? Right there? 2. Nope. Out there. Because that bubble goes all the way into 1. So that's not it. So keep coming around. Right there. There's the bubble that points to 2. Right there. So if I come down, that is 656. So that will be 6.56. And where's that going to fall on our range? Right there, 6.56. It's going to be just barely over the line because 6.5 is on the line. So 0.56 will make us red.
If it was 6.5, would it be red or orange?
I would take either if it fell on the line. I would take either color. Okay, I wouldn't mark it wrong. All right, so the 20 is the one I told y'all to skip. That's why up here on the board it says first period next to number 3. We got to fix that for y'all. 21 I said skip because I forgot to draw the model. 22, how does the speed of light compare to the speed of gamma rays when the speeds are measured in a vacuum? Anybody know?
Moves faster.
In a vacuum, they're going to travel at the same speed. In a vacuum, it means there's nothing to slow it down. There's no gravity, there's no friction, there's no resistance. So they travel at the exact same speed. Okay? What is the color of visible light with the shortest wavelength? So when you look at shortest wavelength up there, the visible light, the one with the shortest wavelength will be what? Violet. All right. Which type of EMR has the highest frequency? Frequency would be down there at the short wavelength, so it would be gamma rays. When does the emission of light occur? When an electron goes from the excited state to the grounded state. Go, Franco. All right. And which of those quantum leaps would be associated with the greatest emitted light? First of all, do we go up or down to be emitted? Down. So we can automatically chuck B and C, because both of those go up, right? They go from 2 to 5 and 4 to 5, so they're out. So we're looking at answers A and D. So which one is a greater leap?
A.
A, because it goes from 5 to 1. All right, are we okay with the questions on homework? Anything you want to ask? What did you say? 22. In a vacuum, all speeds of light travel at the same speed. All of those up there, whether we're talking gamma, X-rays, ultraviolet, infrared, whichever one, they all travel at the same speed. Nothing is faster than the other in a vacuum. Anything in a vacuum travels at the same speed. There's no resistance.
Wait.
But
The vacuum.
it's not your notes, I just told you that. What else is bothering you? Questions? Anything you want to ask? What's it say on the board?
What?
16, when an electron goes from the ground to the excited, it absorbs energy. Anything else?
All the stuff that's gonna be on the quiz.
Anything from 1 to 26? So far it's been okay. It's early. Usually only sucks from 2 to 3. 2 to 30.
Fourth period.
Pretty much. Alright, so if you will, you need a writing utensil, your orange reference table. I don't think I put anything on there that needs a calculator today. Let me check. Can't remember. I did or I didn't. No calculator. Don't need one. Except I do have to alter one question because I refuse to make out a separate quiz for y'all. So I have to change number 9. No, you gotta make it up by tomorrow afternoon. Sure. I can do that. Yep. you need one sheet. All right, for number 9. Let's see, what do I want to put there?
Nothing.
Sure I do. That's number 9 for y'all. For question 9, that's what you're doing. Because y'all haven't done Bohr's theory. Well, I get Xavier his quiz.
It's all this, you said all this at the bottom is wavelength, right?
Yeah.
Okay.
I have a question. I forget what it is later. None of you are still working. Okay.
What are the lines back?
Hmm.
Oh,
Justin? I know.
yeah. Now look at the board.
Can you what?
Look at that.
Can you do what?
Look at that thing.
Yeah. I'll do a lot for you, but yeah.
Oh. And not all quantum energy are the same.
No, they're not. Sure. All right, put your finishing touches on it. All right, can I have them?
Take it away, Ms. Coleman.
All right, scratch your purpose to the front. If you know it, you've answered it. You put yours on the desk, so it's not, so great, it's wrong. Because I'll just start marking things and not pay attention to the questions. If you need to. I'm sure you haven't used all your hall passes.
And this goes to we get extra credit for all passes?
Yep, at the end of the semester, so in late December. That leaves you with one, Michaela. Alright, so if you will, find your notes. We don't need our orange charts anymore today. Y'all just need your notes. You don't need a calculator, so if you have a calculator, you can fill that up too. Don't need it,
Just now.
so you don't, yeah, just notes. No.
Are we done with this little worksheet?
Yes, we are. We're gonna do what I like to do today. It's one of my favorite topics to teach.
The last one? Oh, I don't even remember, I met someone. Since we started. This is like this. No, I don't wanna know what I made right now.
I want yesterday's. Oh, yesterday's were pretty good, I thought.
I didn't want to know like what the answer was.
Oh.
I did wrong.
No, because I got people who gotta make it up, so I won't return it Friday.
What?
All right, so let's finish out Bohr, and then we need to move on to car numbers. All right, so what we didn't get to yesterday. Was one slide. So we learned how to read Bohr's model yesterday, but we didn't talk about the 3 parts of Bohr's model, and that's what we need to do. All right, so on your homework last night, I told you to skip a question because this is the only part we didn't get to yesterday, which are the 3 parts of Bohr's theory. Bohr's theory is often called the planetary model because y'all swore up and down that y'all didn't do this in middle school. Of course, y'all never talk to me. Second period does. But yesterday, when we drew the little model, and I drew the rings, and I drew the dots like this.
E circle.
It's electron.
Oh.
Y'all are as bad as third period when they said the same thing. How many times have I drawn an E for an electron this semester?
Okay, but you usually do the little dash.
That's exactly what they said. I just left the dash off.
Without that, it's just the E.
Yeah.
Does that help?
Yes.
All right. It's often referred to as the planetary model because if you look at it, when people draw it or build models, it looks like planets circling the sun. All right.
The first one doesn't make sense. The sentence.
Now, the electrons circle the nucleus in fixed energy ranges called orbits. So, what he's saying is these little rings, okay? These little rings equal orbits. Now, it's also wrong. Even though we all still teach it, particularly at the elementary level, not the elementary, middle school level, we still teach it in other science classes. I will teach it in physical science. It's technically wrong. Okay? Electrons do not live on those rings. They live in what's called orbitals, which is what I'm going to talk about today. They live in areas that are called 3-dimensional regions of probability. So, for example, if Michaela's mom showed up now to pick her up from school, Ms. Beverly would look in the computer. It would say she's supposed to be in room 29. Does she have to be in room 29?
No.
She could be in the bathroom. Miss Kinney could have called her down to guidance. She could be anywhere in the building. But the greatest chance of finding her would be room 29. Now, it's not that Bohr's theory is completely wrong, but it's almost like they're not on rings. They're in the region or the vicinity of the rings now. All right? He said that the electrons could only move up and down between the orbits, sort of like rungs on a ladder. You had to move between this ring and that ring. That's also wrong because you don't have to be on the ring. All right? The only one that he has correct is number 3. So if you look at these as ring 1, 2, and 3, all right, he said the electrons closest to the nucleus are lowest in energy. So ring 1 would have the least amount of energy. Ring 2 would then have the least beyond that. And then ring 3 would have the most energy. So the further you get from the nucleus or further away, the more energy you have. So if we're by the nucleus and y'all are the electrons in the ring, Elijah, Sumatra, and Daniela, who are the furthest away from me, y'all will have more energy because you're further away. Trevor and Janiyah and Raylena, who are the closest to me, they would have the least amount of energy. Those electrons in rings that are closer have less energy. The further y'all get from me, the more energy you have. Does that make sense? Okay, that's the only part that Bohr had completely correct. Everybody there? Yes or no? Okay, you understand what I'm telling you? So those rings are called orbits, and the electrons had to be on the rings. They could only move between the rings, sort of like rungs on a ladder. Can y'all hover between the rungs on a ladder? Princess, can you hover between the rungs? Nope, electrons can't either. They had to be on the rings. Okay? They wanted to go from one ring to the next, they had to step on the rings. Alright? The further they get from the nucleus, the more energy they have. If they're closer to the nucleus, they have less. That's the only part that's right, is number 3, about the energy. The other 2 parts are wrong. Why do we need to know them if they're wrong? Because the state said so.
But they're considered right on a test.
Right.
Like,
You have to know the theory behind it. Once upon a time, we had to know who discovered the nucleus, who discovered the electron, all the parts of the atom. They've taken that off. This part they've not taken off the test.
Did Steve tell you to tell us that they were wrong?
I'm not going to tell you it's Bohr's theory and not tell you the parts that are wrong. That would be the point. I'm getting ready to tell you who corrected it and teach the correct parts. All right, are we all caught up?
no.
All right, so who came along and fixed it? All right, so the guy who fixed it is an Austrian scientist by the name of Erwin Schrödinger. Okay, Erwin Schrödinger. All right, he's known as the father of modern quantum theory. Okay, he's known as the father of modern quantum theory. He said that electrons are found in orbitals. 3-dimensional regions of probability. Now, it's not that the rings are completely wrong, but instead of being a ring, it's more like a shaded area where there's a higher and lower chance of finding them. The darker area would be where there's a greater chance, the shaded area would be a lesser chance. Could the electrons be between the rings? Yes. There's just not as great a chance of finding them there. Okay? They don't have to be on a ring. Now, Schrödinger wrote a mathematical equation. Somebody close the door. All right. Schrödinger wrote a mathematical equation describing the location of electrons in an atom. The 4 quantum numbers come from this equation. Okay? Now, I'm never going to write this equation on the board. A, it would fill the board. It's a bunch of Greek letters. All right? You don't ever have to know it. We're never going to talk about it. So, don't worry about that. But from this long Greek equation comes the 4 quantum numbers that we're going to learn about today. All right? Because these 4 quantum numbers describe the location of an electron in an atom. Okay? It's the basis for how we picture electrons in an atom. It's the basis for the entire periodic table. and it's how you understand bonding between elements. So, it's huge for us for the next 4 weeks. After I finish today, some of you are going to be a little lost. Okay? Hopefully by the end of tomorrow, I will have picked up my strays who are lost. Okay? What's wrong, Elena?
I'm always lost.
It's okay. Hopefully by the end of tomorrow, I will have found you. Some of my sheep may be lost by the end of today, but hopefully I will have gathered them all up by tomorrow. Okay? Everybody with me? All right. If there's a quiz tomorrow, you listening to me? You got to know the 4 quantum numbers. You got to know their symbols. And you got to know what they tell you.
Is that all the quizzes that be on?
What I just said.
Yes.
What are the 4 quantum numbers? What are their what, Xavier? The symbols. And what they tell you. You got it? Okay. Y'all are going to ask me at the end of class tomorrow. What'd you say, Miss Wall? And then you're going to swear I didn't tell you. All right. So, the 4 quantum numbers. Number 1, principal quantum number. Has the symbol M. Number 2, we're going to call it the orbital quantum number. If you have to take a chemistry class in college and your professor wants to be really, really technical, he may call it the azimuthal quantum number. Very few people use the old name of azimuthal quantum number. Some still do. Most people use orbital. All right. The magnetic quantum number. Just waiting on it. And the spin quantum number. Okay, those are your 4 quantum numbers, and there are their symbols. There's 2/3 of what you got to know when you return to me tomorrow. Okay? Principal, orbital, magnetic, and spin. Principal, when I write the N, you have to be able to tell me that stands for principal. When I write L, you have to be able to tell me that stands for orbital. M, that's an L.
Well, wait, so
Not
we
neat.
just write a regular lowercase L?
If you want to write a regular lowercase L, write it that way, but it looks like an I when I do it. All right, magnetic is M and spin is S.
So
It's
we
an
write
L.
like that on the test.
It will be italicized.
Wait,
Oh, I probably capitalized it. I used Comic Sans.
I'll see what you meant if we wrote it just like that. Because it looked like a breast cancer symbol.
It looks like a breast cancer symbol. Okay,
I can write it like that.
you can write it like that.
So we write like that, it's not wrong.
Huh?
I write like that, it's not wrong.
No. All right, we're gonna start with principal. All right. So, what does the principal quantum number tell us? The principal quantum number tells 2 things. Okay? It tells size and it tells us the energy level. Okay? It tells size and the energy level. So, if n equals 1, what does that mean? We're in the first energy level. If I say n equals 3, what's that mean? Good.
Is that like the board model?
Yep. You can visualize it that way for right now. If n equals 5, because that's the way I'm going to draw it, we'd be in the 5th energy level, right? Now, and the principal and the spin have the least amount of stuff to talk about, by the way.
Are these examples or do you know that?
Are what? Those are examples. Okay? So, how does it tell us size? Well, if I was to draw that, n equals 1 would have how many rings around the nucleus? 1. If I was to draw n equals 3, I'd need how many rings? So who would be bigger, a first energy level or a third energy level? The third, okay? So if I drew an n equals 5, all right? Do you see how energy level tells size? Okay? More energy levels. Let me get another color here. All right, so more energy levels equals bigger size. Does that make sense?
Bigger size what? Like what are you talking
A bigger atom.
about?
Okay, so can you see that only having one energy level made our atom pretty small, and 3 energy levels made it bigger, and then 5 made it much bigger? Okay, so more energy levels is going to make us bigger. Does that make sense? Okay, so how many of these energy levels can I have? What can my values or my numbers be? Because we're going to do this with all of them. They're called the quantum numbers, not the quantum letters. So what numbers can we assign to n? Okay? One through what?
6,
One more.
7,
Okay. 1 through 7 is currently what we have on the periodic table. We don't have any elements to go beyond 7. However, it can be any whole number.
Wait, so this is still the principal?
It's all still the principal quantum number. All right?
What? You just said it's 1 through 7, but it possibly.
Well, if we're in the 7th energy level and we excite an electron, where's it going? It has to go up, right? So it would have to go to what energy level?
6.
If you're in energy level 7, you have to go at least to 8. Okay?
Well, there isn't.
It's got to be an 8 to be excited. Secondly, what if we discover another element? What energy level will it have to go in? All 7 rows of the periodic table are full. All those elements have been discovered. Okay? So, where are we going to have to put a new element if it's discovered? It would have to go in 8. Okay? That's why I'm telling you it could be a whole number. So, for all practical purposes, it's going to be at least 1 through 8. All right? Since I've been teaching, we've filled in all the elements on the 7th row. Okay, so the next ones will go on the 8th row. All right, the orbital quantum number. Now, this one's going to take a bit. Or L. All right, this one tells sublevel and shape. Now, it's going to take me about 3 boards to do this one. Okay? So, we're going to be in orbital for a bit.
Oh.
wait, an example or?
No, and how to finish this one. I'm just telling you ahead of time, so it's going to take a little bit. So, we'll start with sublevels. So, the sublevels have names. Their names are S, P, D, and F. It does not matter if you learn the quantum numbers in order. I don't care if you know them as principal, orbital, magnetic, and spin. You can come back tomorrow and know them in any order. The sublevels must be learned in this order. S, P, D, F. People have come back and told me they're spoof. I don't care how you memorize the names. S, P, D, F have to be learned in that order. Now, going back to what we just did. If n equals 1, all right, what did we say that was just a second ago? Very good. All right, we have one energy level. We're in the first energy level. Now, that also tells us about our sublevel. All right, the number of the energy level equals the number of the sublevel. So, if I'm in the first energy level, how many sublevels can I have? I can only have one. So if I'm in the first energy level, I may only have one sublevel. Okay? My energy level matches my sublevel. So, one energy level, one sublevel. I need to write its name. So, what is the name of the first sublevel? So I write S. Now, I'm in the first energy level. So what am I going to put on the front of it? We're going to put a 1 on the front of it. So it's called 1S. That's its name. So if I do n equals 3 like we had on the last board. All right, what energy level am I in? I'm in the third energy level. All right. How many sublevels am I allowed?
3.
Okay, if I have 3 energy levels, that means I'm allowed 3 sublevels. So, this time, I have 3 sublevels. I have 3 different names. So, what are my 3 different names?
S, B, C.
Okay, so S, P, and D. So I said you had to learn them in order, no F. So, what goes on the front of all 3 names? The 3, because we're in the third energy level. 3S, 3P, and 3D. Now, we put the 3 on the front because notice we have an S in the first energy level. We have an S in the third energy level. So that 3 designates that the 1S and the 3S are different because they're in a different energy level. Okay? Sort of like in fourth period. So I will use Allie. I have 2 Allies. I got one in first period. I got one in third period. Their last names denote that they're different. So that 1 and that 3 denotes those 2 S's are different. Okay? Does that make sense?
Yeah.
Now, what happens when I go to n equals 5? How many sublevels do I have? We know we're in the 5th energy level, right? So we have 5 sublevels. And what will their names be? 5S, 5P, 5D, 5F, and 5 somebody. We don't reloop the names. Thank you, Zaria. All right. We don't reloop the names. We just know that it will be 5 somebody. We don't have enough elements on the periodic table to need to worry about that 5th sublevel. Okay? We just don't worry about writing its name. Okay, what? It does. We will only name how many of the sublevels? The first 4. There would be 7 sublevels, but we will only name the first 4.
So if there was 7 in the first 4 would have S, B, and the last 4 would have question mark?
Well, we wouldn't even worry about naming them. We'd only name the first 4. Okay? All right, we're good so far with how to write their names and how to figure out how many sublevels. All right, let's talk about shapes. So, S has, all right, because these are 3-dimensional, there's an X, Y, and Z axis. Its shape is a sphere. Yes, you have to draw it. Okay? It will have a spherical shape. Don't take 8 years to draw it.
Wait,
P. What? Why am I scaring you? This one can be called a peanut, a dumbbell, or two lobes. All right. Now, D and F, I can't draw F at all. You'd have to look that one up online. It's called a flower, but it's got so many offshoots, I can't even attempt that drawing. The D has 4 lobes, and there's one that sort of has a circle and some angel-looking symbols above it that I can't really draw well either. But the S and P are the only 2 that I want you to be able to actually draw. Now, notice that I drew the P. And what's different about the 3 P's that I drew? What has what? I can't hear you. Say it loud, nobody can hear you.
one is a Z, the other one has 2 lines.
All right, one's on the Z-axis, and where are the other 2? The Y and the X. So, to name the P orbitals, okay, we name these PX, PY, and PZ. These also have names, but you're never going to have to know these names because these names get much longer based on the axes these fall on, but you're not going to have to know those. Okay? But you should be able to look at the P and be able to tell it's on the X, Y, or Z axis. Okay? Now, the reason I drew those axes, even though I didn't put anything on them, comes into the next quantum number, which is why I made you draw it. All right, has everybody caught up? No. Come on, just draw some X, Y, and Z axes. Landon's like, when does this end?
Are y'all the same?
Or what all the same?
D.
D, yes, they're all the same. They're all just draw 5 X, Y, Z axes. I just drew one so that you can see what a D looks like roughly. And F, I can't draw at all. You have to look that one up online. My attempt at that is really bad. Is it bad at what?
Does it matter if the letters are lowercase or not?
All right, how about now? We got it? Okay. So, like I said earlier, these are called the quantum numbers, not quantum letters. So, we have to assign a number to the sublevel.
Wait, so we have to draw like all of these pictures every time we do this?
No.
We just draw one.
We just got to know the shapes.
How many deep do we go?
5.
What do you mean know the shapes?
If I ask you the shape of a D sublevel, you need to be able to tell me it's what shape.
Or love?
There you go.
I don't even have to draw it.
Not if I don't ask for it, because I'm not going to ask you to draw a D. I'm going to ask you to draw a P or an S. The reason you draw those axes is going to tie into the next quantum number. It's also going to tie into Friday's electron configurations, orbital notations, and dot diagrams. There's a method to my madness. Just write it down. Stop whining. Now, they're called the quantum numbers, not the quantum letters. You'll survive the layman's. So, you guys have a physical address, right? The electrons have a physical address. All right? This is their address. These are their quantum numbers. So, what were the 4 quantum numbers again in symbols?
Alright.
Okay, very good, Janiyah. So, this is N, this is L, this is M, this is S. We haven't done these 2 yet, so don't worry about them. These are the 2 that we have done. So, these are the 2 I'm asking you about. So, what did N stand for just a couple minutes ago? Size and what else? Energy level, okay? So, this right here tells me the energy level. So, what energy level does it tell me I'm in?
3.
I'm in the 3rd energy level. Okay? Now, that tells me in a physical location, I'm in 1, 2, 3. I'm on the 3rd ring. That's what that tells me. Now, this tells me what? This tells me the sublevel. Very good, James. This tells me the sublevel. Again, they're quantum numbers, not quantum letters. So I have to know what letter that 1 stands for. So which sublevel is a 1? That's what everybody will assume the entire time we do this, Allie. I thank you for making that mistake. Okay? Because everybody will do it the whole time. They always go S is 1, P is 2, D is 3, and F is 4. You have got to remember that S starts at what number? 0. Okay? And Allie made the most common mistake that everybody makes. And they're going to do it second period too, so don't feel bad. Okay? Everybody does it. Okay? And we'll be doing it for days. S starts at 0. P is what? 1. So instead of it being an S sublevel, when you see L equals 1, you have to know that translates to P.
Okay.
So we're a P sublevel. So we're in the 3rd ring, and we're a P sublevel. Yes, ma'am.
Then, like, earlier, when we were doing, like, the N equals 3, 3rd energy level, 3 sublevels, 3S, 3P, 3D.
So all we know is we're in the 3rd ring, and we're in a P sublevel. We're not in the S. We're not in the D. This tells me we're in the P. 3P. Now, we don't know if we're in this P, or this P yet, because we haven't done the next quantum number. We're somewhere in one of those 3 places.
So what's the difference in the type of questions that will be asked?
We're not that far yet. Don't get there yet. We're going. We're not there. Okay? You're too far ahead of us. All right? So that's what we've done thus far. The 3rd quantum number is the magnetic quantum number. Okay? Go back. Now, the magnetic quantum number tells, and you can say this two different ways, and I don't care which way you learn it. You can tell me that it tells orientation in space, or you can tell me the number of orbitals. Depends on the teachers to which one they teach. I tell both because I don't really care which one you learn. Okay? It's your option. Now, this is why I made you draw those stupid X, Y, and Z axes, because those tell you the orientation in space. All right? So, we have how many sublevels? We have 4. Now, the X, Y, and Z axes tell you the orientation in space. So for the F sublevel, how many different ways could the S sublevel be oriented in space? That tells you the orientation then. There's only one orbital or orientation. Okay? If you go to P, how many different ways could it be oriented? That is one orbital, that is the second orbital, that is the third orbital. Okay? You can look at it as 1, 2, 3 orbitals, or you can look at it as 1, 2, 3 different orientations. It doesn't matter which way you think of it as an orientation or an orbital, but there's 1, 2, 3 of them. Do you see how we got that? Okay. So for D, this is the reason I told you to draw those. There are how many? There's 5. And for F, there's how many? Everybody with me?
Wait, for D, there's 5?
There's 5. Did you draw 5 for D on your paper?
Oh, I just did 4.
Okay, now let's go back for a second. You remember when we were making up those theoretical numbers a while ago? And we said, what if you had a 5th energy level? And you had to have a 5th sublevel? We said there are only 4 that we were going to name, right? What if you had a 5th sublevel? Do you see the pattern?
Yes.
What would this fictitious number 5 have for the number of orbitals or orientations?
9.
It would have 9. Okay? We don't have to name it for you to figure out how many orbitals or orientations there would be. It's a mathematical pattern. How did we go from 1 to 3? We added what? What did we do here? What do we do here? So what are we going to do there? If you added another one, you would do what? Okay? It's just a pattern. Now, how many electrons can go in an orbital? The number of electrons in an orbital equals 2. Okay? Those of you who may have ever done Bohr models in middle school and learned how many electrons could go on a ring, this is where some of this information came from. And your teachers probably just taught you the rules for the rings, but this is where it's coming from. So, if S only has one orbital, how many electrons can go in that one orbital if 2 electrons can go in one ring?
2.
Okay. If there are 3 orbitals, it can have how many electrons?
6.
D can have how many? And F can have how many? So essentially, each picture can have 2 electrons. You with me? Because is this the next one where I lose people?
Wait, so this is all for the magnetic one?
One more thing. That's where I lose people. It's the last piece. Hopefully I'll pick you up tomorrow. Everybody there?
Sure.
You'll say, it's not that hard one. You got to try. Instead of just telling me you're lost. All right. The last piece of the magnetic quantum number is the value of M. Now again, they're the quantum numbers, not the quantum symbols. We can't be drawing X, Y, and Z axes in the address. We have to assign those numbers. All right?
Wait, M is this its symbol, right?
Yep.
Okay.
Okay, M is assigned a value of minus L to positive L. So in order to do the magnetic quantum numbers value, you have to know the value of L. So, what was the number assigned to S? Try again.
Zero.
See, I told you we'd be doing this for days.
Well, then why?
L is equal to what? D is equal to?
Why does that have one orbital then? Yeah.
The picture is assigned a number, okay? The value of the sublevel and the picture are not the same thing, okay? So the value, this is L equals 0, is like your house number
But
and your address.
That's with orbital, right?
Yes,
Okay.
yes,
And then the magnetic is the number of orbits.
yes,
Okay.
correct. Okay, so to calculate this, M is equal to minus 0 to positive 0. So M will be equal to what? 0. Now, that is the number that's assigned to that X, Y, and Z axis. Now, for S, there's only one of these, so we only have one number. When we turn around and do this for this one, it's minus 1 to positive 1. So in math class, we get minus 1, 0, and positive 1. And we have 3 of these, so we get 3 numbers. Each of those X, Y, and Z's gets one of those numbers. Now, you don't have to know which number goes to which of those little X, Y, and Z axes. You just have to know that one of those numbers is for one of those X, Y, and Z axes. Does that make sense to anybody?
No.
Hopefully it will tomorrow. Okay?
Is tomorrow when we're practicing all this or something?
We're going to practice it tomorrow too. I already told you what's on the quiz.
Yeah, but that's all this and all this is confusing. No.
What did I tell you was on the quiz?
Symbols?
It's what it sounds like, what it
Symbol
is.
and
Okay. Princess is shaking her head like a dog over there, like, oh my God, I just woke up and what have I missed? You tired today? I'm sorry. Oh, I didn't mean to. Precious. Wrong one, sorry. Precious. I'm sorry it's warm up. Can't fix it for you. So, when you look at that, how many numbers does M have for the D sublevel? How many numbers does D have?
5.
Okay, look back in your notes. How many pictures did y'all draw for D? All 5 of those numbers are for the 5 pictures you drew for D. All right, how many numbers do you have for F? Because you have how many pictures for F? 7. Okay? Now, the last quantum number is the easiest of them all. It's also the shortest. All right, is the spin quantum number, or S. Now, you have to make sure, if it asks about S, it says the spin quantum number, or S quantum number, or S sublevel. You have to pay attention to that since there's two S's. Okay? Now, this tells the spin of the electron. You make sure I underline electron, not the spin of any energy or any other weird stuff. It's the spin of the electron. Now, because there are only two electrons in an orbital. Okay? There are only two electrons in an orbital. Okay? In a room. Two electrons in the same room. They spin in opposite directions. Okay? The two electrons spin in opposite directions. They don't spin in the same direction. So we describe these as being clockwise and what? That is right. So, since we're going to describe them as being clockwise and counterclockwise, their value or number is positive and negative 1/2. Now, you do not have to assign positive for counter and negative for clockwise or vice versa. All you have to know is they're assigned a positive and a negative so that you know they're opposites of each other. That's it. Okay? Neither of them are assigned one versus the other. Questions? You okay over there, Zyra? All right. Think we can practice? Too bad. Everybody got what they need?
No.
Then when you got it. It was really a rhetorical question. I was just trying to give you a little input. We're going to do 6 that are pretty easy. 3 that are really easy and 3 that have just a tad more challenge.
Got it.
Everybody got it now? You all miss the math yet?
Yes.
Yeah.
All right. I don't care. This is as easy as it gets.
Oh.
See, number 1 would be fair game for tomorrow, because that's what does it tell us? Yes, ma'am. Am I staying today? Yeah, today and tomorrow. Remember, makeup works through tomorrow, so yeah. And I have makeup labs with like 4 people in here today. I got 2 stations set up because I think I have 6 people coming today. 2 from second and 4 from in here.
So you have to write down the whole thing, like the biggest difference.
You have to write down what?
Do you have to write down like, not saying this is right, but do we have to write down orbital quantum number or do we?
You can just write orbital.
Not saying that that's right.
Can we talk about number one?
Yes.
Which quantum number tells shape?
Orbital.
Orbital is correct. If n equals 2, how many sublevels do you have? 2.
2s and 2p.
Yes. 2s and 2p. Are we okay on that one? Yes or no? Okay. If you have 2 sublevels, remember the number of energy levels has to equal the sublevels. Okay? Energy levels equals the sublevels. So there have to be 2. If you have 2 sublevels, you take the first 2 names. So S and P. We put a 2 on the front. All right, how many electrons can D hold? How many pictures did D have? How many can go in each picture? How many can go in each picture? 2. 2 in each picture. So 2 times 5 is 10. Each picture holds 2. 2 electrons in an orbital. So 5 times 2 is 10. Now the remaining 3 have a little more. What'd you get for number 4?
6.
Nope. I got any other answers besides 6? 14's warm.
3.
I haven't heard the right answer.
1, 2.
I'm pretty sure it's on the homework sheet. We'll see if you come up with it by tomorrow. Can 1p exist?
No.
No, why not?
Because you would need at least 2 sublevels to use the p. And
That is correct, Franco. Very nice. All right, a p sublevel. Huh? In order to have a p, what sublevel is it?
2.
It's the second sublevel, right? So in order to have a second sublevel, what energy level do you need to be in? 2. And 1 is not a second energy level, so you can't have a second
And I
sublevel.
don't even know where to start on number 4.
Number 4, I said, see if you can figure it out by tomorrow. I will.
What section of my notes should I look at?
It's an application question. What you need? Yeah. If you don't get it, it's okay. I'll teach it to you tomorrow. I'll even teach you a shortcut. How many electrons can you put in 3p?
6.
Doesn't matter that it's 3p. It's a p. The p can hold how many? P can hold how many pictures?
3.
And how many can go in each picture?
2.
So those people who said 6 have the right answer. The 3 does not affect anything. It's still 6.
So if it's just because p, it's always going to be 6.
6 is always going to be a p. Doesn't matter if it says 3p, 4p, 7p. P is 6. Now, answer them all. Oh, cool. All of them.
Oh my gosh.
If you forget what's on the quiz, ask Janiyah, because she's the only one I've heard who can quote it every time. Who too?
Yeah.
Who else said they could do it every time? Sam. All right, that's Sam. Sam and Janiyah are your go-to people if you forget. What's on the quiz?
Oh,
Because some of y'all are still bumbling around going, we got a quiz? What's on the quiz? Ms. Wall didn't tell me. Yeah, I did.
So the 4 numbers, the symbols, and what they tell us. Yeah.
Ask them. I already told you 3 times.
Are you serious?